Okay, guys, here to help you out on the second day of working on rational functions and their graphs. So today we're going to take what we did, but also make sure we can identify the horizontal asymptotes. We want to make sure we can also identify all parts of discontinuity and then be able to state the domain and range. So basically put all the key features of the graph together here. So horizontal asymptotes, remember those are where the graph kind of meets at a certain line here. Goes down to two things. Now remember, P is the top function, Q is the bottom function. Here we go. Took a second for my pen to get working here. Now, if the degree of P is bigger than the degree of Q, and if you need to write that, that'd be something like x cubed over x squared. Okay. If the degree on the top is higher than the degree on the bottom, all right, there is no horizontal asymptote. Okay. It would go up towards infinity or go down towards negative infinity. Okay, next, if the degree on the top is less than the degree on the bottom, okay, what it will be is that the horizontal asymptote is going to be y equals 0. Okay, so if the degree on the bottom is bigger than the one on the top, a horizontal asymptote would be y equals 0. So that graph would look something maybe like this. Goes across the line. All right, now, if the degree on the top is the same as the degree on the bottom, okay, I'm going to say like 3x squared plus yada, yada, yada. And then on the bottom would be like 1x squared plus yada, yada, yada. It doesn't matter what the rest is. We're looking at degree. It's going to be equal to the leading coefficients. All right, so if you look at this example that we have here, the leading coefficient is 3, the other leading coefficient is 1. So this one would be like y equals 3. Now it all depends. And so what that graph would look like, 1, 2, 3, would be very similar to this one here, except where there'd be like a shift. All right, so let's go through and see, can we figure out what the horizontal asymptote for each one of these? All right, so if we look here, we got to look at the degree. The degree here is 1, the degree here is 1. So the leading coefficients are, the degrees are the same. So the leading coefficient is going to be -2 on the top, 1 on the bottom, because that's 1x. And so the horizontal asymptote would be y equals -2. All right, now here, the degree on the top is 1, the degree on the bottom is 2. 2 is bigger, and if the degree is bigger on the bottom, it's going to be 0. Okay, y equals 0. All right, now on this one here, degree of 2 is on the top, degree of 1 on the bottom. If the degree is higher on the top, there is no leading or no horizontal asymptote. Okay. So the domain is all the possible x values that are included in a function. So this would be the real numbers except for any number that creates a hole or a vertical asymptote. Asymptote. Okay, so remember that's where the denominator equals 0. The range, on the other hand, is a list of all the y values. That'd be any real number except for the ones that create a horizontal asymptote. And that's why, oh, I kind of misspelled there. Asymptote. Okay. So this is why when we looked at the discontinuous points, we said like x equals, what, and horizontal asymptotes, we've been saying y equals, because it correlates to the domain and range. All right, so let's do these problems here. I think I gotta zoom in out a little bit. Okay, that's better. All right, we're gonna name the holes. We're gonna name the vertical asymptotes, list the horizontal asymptotes, name the domains, the range, and the x-intercepts. Okay, so the holes, let's remember here, let's factor the top here so we can really figure out what's going on here. Now this one, we gotta do the riddle here. What two numbers multiply together to give us 6, add together to get 5? It's 2 and 3. So really this is x plus 2 and an x plus 3 over x plus 2. Okay, so we have a discontinuous point at x equals -2. So that means we have a hole at x equals -2. All right, there are no vertical asymptotes because this is the only discontinuous point and it gets canceled out here. All right, our horizontal asymptotes, we're going to look at the degrees. This is what we just went over. The degree is 2 on the top, 1 on the bottom. If the degree is bigger on the top, there is no horizontal asymptotes. Okay, now the list of the domain is a list of all x values. So it's all real numbers, except x cannot equal -2. We cannot have it equal to -2 because there's a hole there. Another way you could write this, and I wouldn't recommend it doing it this way, but you could say it's every number from -infinity to -2, and then from -2 to infinity. Basically, you're saying every number but -2. I prefer this method. It's easier, quicker to write. All right, now our range. Our range is going to be all y numbers except for a horizontal asymptote. This one does not have a horizontal asymptote, so it's all real numbers. All right, now our x-intercept. Our x-intercept is going to be where our numerator equals 0. And our numerator here, we would set the top equal to 0. We would get two numbers here. One would be at -2. The other one would be at -3. All right. But if we set -2 would not work because it is a hole. So the only x-intercept is at -3. The x-intercept is when the top equals 0. So just to kind of go through, let's maybe add some notes here. All right, our holes. Bottom equals 0 and cancels. All right, so we set the bottom equal to 0. If it cancels out from the top, that's a hole. Vertical is where our bottom equals 0 and does not cancel. All right, our horizontal asymptote. Let's call it the degree rules. We'll look at the degrees. And we're going to figure out, is one bigger? Is one smaller? Are they the same? Domain. All x's except holes and vertical asymptotes. Okay, we didn't have any vertical asymptotes. We just had a hole. So we said it's all the numbers except x cannot equal -2. Range. We're talking about all the y's except our horizontal asymptote. We didn't have a horizontal asymptote, so it is all the y's. It's all real numbers. And then our x-intercept is when the top equals 0 except the holes. Okay, so let's use that rule here. If you want to try this next one on your own, that's kind of good. Let's see if we can follow this. So we got to completely factor this top here. The top is a riddle factor. What two numbers multiply together to give us 36, add together to get -12. That'd be a -9 and a -3. So this would be an x minus 9. Oh, no, it's not. Or is it? So or is it -6? Yeah, -9 times negative. Wow. It's -6 and -6. Wow. All right, so we got x minus 6, x minus 6. 9 times 3 is not 36. All right, now at the bottom here, this is the difference of squares. That'd be an x plus 6, x minus 6. All right, and so if we look, this x minus 6 would cancel out one of these x minus 6s. All right, so where are the holes? Our holes would be when x equals positive 6. That is the one here that cancels out. Our vertical asymptote is x equals negative 6. Okay, well, that cancels out here. Now, our horizontal asymptote, we're going to go back to this one here. Our degrees are the same, so it's going to be y equals, we look at the leading coefficients, 1 divided by 1, so our horizontal asymptote is when y equals 1. Okay, our domain is all the x numbers except x cannot equal 6 and x cannot equal negative 6. Those are our two discontinuous points on the bottom. Our range are all the y numbers except y cannot equal where we have a horizontal asymptote. Y cannot equal 1. All right, and then finally, our x-intercept. We're going to look at the top and see when does the top equal 0. Okay, so our top would equal 0 here when x equals 6. Now, we do have a hole here at this one. Okay, so does that one cancel out? Good question. It would. That is a hole. Actually, in the simplified version. That is a hole, so there is no x-intercept. Okay. Now, in our simplified version, there would be an x-intercept, but it'd still be a hole in our original graph, so it doesn't work. It doesn't exist. All right, guys. So we're kind of wrapping up this whole little small chapter here. You guys got a couple problems to do on your own. You will do the same here. You'll find those holes and x-intercepts and answer that Edulastic. If you guys have any questions, make sure you reach out. If not, thanks for watching. You guys have a good one. See you later.